So for parallel and perpendicular lines, parallel lines have the exact same slope. And in looking at an equation, where the slope is noted is the coefficient of x. So in this equation, y equals 2x plus 5, 2 is the slope. In our other equation, y equals 2x minus 3, 2 is also the slope. And parallel lines never meet, meaning they never intersect. They go on and on forever and never cross. Perpendicular lines, when comparing their slope, they are opposite reciprocals of each other. So comparing these two equations, y equals 2x plus 1 and y equals negative 1/2 x plus 1, their two slopes are opposites, so one is positive and one is negative, and they are reciprocals of each other. So 2 is the reciprocal of 1/2. So perpendicular lines cross to form 90-degree angles, and they intersect at the one spot, and their slopes are opposite reciprocals of each other. So looking at these three examples, if we need to compare if the lines are parallel or perpendicular. So think about this first one. I have the equation y equals 3x plus 5 and y equals 3x plus 8. Would these two lines be parallel or perpendicular? These two would be parallel because they both have the same slope. M, or slope, is 3, so that means they are parallel. Looking at question number 2, y equals 1/5 x minus 10, and y equals negative 5x plus 6. Are these two equations parallel or perpendicular? I can see that they're not the same slope. This one is 1/5, and this slope is negative 5. So next, to check if they're perpendicular, they should be opposite reciprocals. I can see they are opposites. One is positive, one is negative, and they are reciprocals. 1/5 is the reciprocal of 5. So these two are perpendicular. And our last one, we have the equation y equals 3/4 x plus 3 and y equals 6/8 x minus 2. Would these two equations be parallel or perpendicular? These two are actually parallel. Even though it doesn't look like it up front, they are parallel. This one has a slope of 3/4, and this one has a slope of 6/8. If we simplify the fraction on the right by dividing out a 2 from each term, 6 divided by 2 is 3, 8 divided by 2 is 4. So it actually has a slope of 3/4. So this, for question number 3, both of these equations are actually parallel. You can also determine if equations are parallel, or what the equation is, if you're given the equation of one of the lines and a point that passes through the other line. So for this example, find the equation of the line that passes through -4, 5 and is parallel. It's parallel to y equals 1/2 x plus 3. So because it is parallel, I know that the other equation needs to have the same slope. The slope in this equation, y equals 1/2 x plus 3, is 1/2. So I know my other equation needs to be a slope of 1/2. And then to write the equation, I can easily see a point on that line and what the slope is. So I'm going to write my equation in point-slope form. So y minus y1, so our y-coordinate, equals m, which is our slope, times x minus x1. And then just plugging in our coordinates, our y-coordinate of this point is 5. So y minus 5 equals our slope, 1/2, times x minus our x-coordinate. Our x-coordinate is -4, so x minus a -4. And then writing it so that it's not minus a negative, we would have y minus 5 equals 1/2 times x plus 4. So this would be the equation in point slope form. If you had to translate it to y or to slope intercept form, which the homework notes, you would have to solve this equation for y, meaning we need to get y by itself. So first step, you want to use your distributive property to multiply through 1/2 times x and then 1/2 times 4. We want to make sure we multiply that slope times both terms. So we would have y minus 5 equals 1/2 times x, so 1/2 x, and then 1/2 times a positive 4, think of it as half of 4, is 2. And last step, we want y by itself, so we're just going to add 5. So they cancel out, and we want to add 5 here. So our final equation in slope-intercept form, y equals 1/2 x plus 7 for our equation that is parallel to the equation listed. They have the same slope, 1/2 and 1/2, so I can see that they are parallel. And it specifically passes through this point because we chose to set it up in point slope form. One last example, finding the equation of a line that is perpendicular. So find the equation of the line that passes through 7, 0 and is perpendicular to x plus y equals 4. So looking at this equation, I can't see right away what the slope is because my equation is not in slope-intercept form. So you first just want to rearrange that equation so that it's in slope-intercept form. So get y by itself. So we would subtract x on each side so that you have y equals, and I'm going to write my x term first so that I can see it's in slope-intercept form. So minus x and then a positive 4, so plus 4. So the slope of this equation, slope is the number, the coefficient of x. Since there's no number there, this is actually a 1. So think of this as a minus 1x. So the slope of this equation is a -1. Now we want the slope for our other equation to be perpendicular to this equation. Perpendicular means they are opposite reciprocals. So the opposite of a -1 would be a positive 1, and the reciprocal of 1 is actually just 1. So the equation we want to use has a slope of a positive 1. It's the opposite reciprocal of the given equation. Now we can set it up in point slope form again, using 0 for our y1 and 7 for our x1. So y minus our y coordinate equals 1 for our slope times x minus our x coordinate, which is 7 from that ordered pair. And then just simplify. Y minus 0 really is just y. 1 times x is x. 1 times a minus 7 is just a minus 7. So here's that equation in slope-intercept form.